Good morning. I will present you shortly one of our research effort entitled Aldehyde emission in relation with the resistant temperature and ironing in secret by Muhammad al-Mubarak, Kariklia Danica, Nikolaos Vlachos, George Lagomensis, Grigoris Volapenko, Konstantinos Poulas from the University of Patras Department of Pharmacy. It is appreciated that one of the main health concerns about electron secret use is the potential for toxic aldehyde emissions, which are known to be formed from heating mixture of PD, VC, and the thermal decomposition product. The level of the aldehyde emission are highly dependent on the temperature of the high heating coil. The objective of this study was to explore the aldehyde emission of mixture of PG and FG liquid 50-50% at different voltage setting and consequently to higher vaping temperature, and to investigate how resistant temperature and resistant ironing influence the emission levels of the aldehydes. For our experimental purposes, a naturalist to 0.7 ohm resistance was used and aldehyde emission were tested at three different voltage settings at 3.7, 4.3, and at 5 volts. Standard vaping conditions were followed for our experimental, and DMPH derivative of all aldehyde tested were measured by UHPLC methods. And figure 1 show the aldehyde emission at 3.7 volt setting of e-cigarette in a total of 60 vaping cycles. Each vaping cycle is equal to total of 30 pairs. We can see that formaldehyde emissions are gradually increasing from the beginning of the vaping experiment at the first vaping cycle throughout the 60 vaping cycles. A quite substantial increase in formaldehyde emission was measured after approximately 30 up to 40 vaping cycles. Interestingly, a more drastic accumulation of formaldehyde emission was observed after 45 vaping cycles and up to the farthest point of 60 vaping cycles. Likewise, aldehyde as well as acrylamide and crotonaldehyde emissions also postulated convertible pattern of emission as for formaldehyde. In figure 2 illustrated the aldehyde emissions at 3.7 volt vaping in our experimental setting are quite comparable to 3.7 volt aldehyde emission profile is observed, yet with some differences. Specifically, aldehyde emissions are evaluated with when compared to the respective vaping cycle at 3.7 volt setting. The pivotal point for formaldehyde was observed beyond 240 cycles of vaping, where an approximately of at least 4 volts indication in the accumulation of formaldehyde emission was observed. In quite similar motif, acetaldehyde, acrolein, and crotonaldehyde emission were measured. In figure 3, we can see the aldehyde emission of the e-cigarette mode at 5 volt in a total of 1 to 25 vaping cycles. As we can see, all aldehyde tests were drastically increased almost immediately after 10 vaping cycles. Interestingly, values of both formaldehyde and acetaldehyde after only of 20 to 25 vaping cycles at 5 volt were convertible in concentration of approximately 50 to 60 vaping cycles and either 3.7 or 4.3 volt setting. Acrolein and acrylaldehyde maximum emission also keep quite low compared to acrylaldehyde and formaldehyde, and the compatible level as with the 3.7 and 4.3 volt vaping modes. Still, in the same way as far formaldehyde and formaldehyde at 5 volts started to increase rapidly after 10 vaping cycles. Our results demonstrate that higher voltage settings lead to higher resistant temperature that may impact on resistant temperature and idling, ultimately resulting in evaluating aldehyde emission level. At 3.7 and 4.3 volt, a sharp increase in aldehyde emission was observed at approximately 1200 PAF, while at 5 volts and similar rise was observed approximately at 300 PAF. Our results indicate a considerable difference lifespan of the electron cigarettes resistant due to high temperatures in the resistant possibly because of higher voltage setting. We believe that our study is giving new insights toward our user safety and promotes better understanding of e-cigarette use. Thank you for your attention.